A warm welcome to one and all. Good morning, TM. A warm welcome to one and all present here. Today, I am Ms. Tayyab and Khushbu Khanna shall be your host for the day on behalf of the Department of Electrical Engineering and Computer Science, FOECS. I feel privileged to welcome distinguished Professor Muktiar Singh Sir, Head of Department of Electrical Engineering, and Professor Kapil Sharma Sir, Head of Department of Information Technology, Delhi Technological University. Respected Principal Professor R.K. Dwivedi, Dr. Garima Goswami Ma'am, HOD of Electrical Engineering, and all the head and faculty members to this expert lecture on future trend and innovation in electrical vehicles. The primary objective of this expert lecture is to develop the design thinking model in the most demanding electric vehicle technology and chemical domain. In the world, fuel conservation and ecological protection concerns are growing, and the electric vehicles research and development has hassled. The automotive industry globally is experiencing disruption by digitalization. Increasing automations are revolutionizing the industry for a new revolution in 21st century, and the Indian automotive industry is also experiencing its effects. The environment-friendly electric vehicles market is advancing in India. The Indian EV market is different compared to all the global markets as Indian economic dynamics. Market requirements and the consumer preferences are different. New car companies are transforming the car industry, creating innovative new models. Interest in the electric vehicles market is growing rapidly, and with the new pricing models, the growth is predicted to get bigger. All existing car makers are aware of this change and are trying to unveil new hybrid or electric vehicle models. There is rising commitments and competitions from leading car manufacturers and businesses within the automotive industry. Energy experts believe that China and Indian markets will drive vehicle demand due to the less carbon emission challenges. Electric vehicles development will be high in these countries' political agenda. Many companies are planning to introduce electric vehicle charging points as electric vehicle industry is growth is increasing. Now, I would like to invite all the dignitaries for the lamp lighting in front of Saraswati. Thank you, Dignitary. Now I would like to Now I would like to invite Professor R. K. Dwivedi to present the bouquet to Professor Kapil Sharma sir as token of respect. Thank you, sir. Now I would like to invite Dr. Gariman Goswami to present the bouquet to Professor Muktiar Singh sir as token of respect. Thank you, ma'am. Now I would like to invite Dr. Alka Verma ma'am to present the bouquet to Professor R. K. Dwivedi sir as token of respect. Thank you, ma'am. Now I request Dr. Garima Goswami, HOD of Electrical Engineering, FOE, to address the theme of this session.
Very good morning, all of you. Respected eminent guest speakers, Professor Mukta Singh sir and Professor Kapil Sharma sir, respected director, Professor Antigiredi sir, all the head of the departments of other department heads and faculty members, and my dear students. Yeah, it's a great pleasure for all of us today that we have gathered over here to enhance our knowledge in the field related to electric vehicles. Although the execution of this event was long awaited, actually the time schedule between us and us couldn't be matched. But now the day has come, and we all are here to listen to both renowned personalities, Dr. Mukta Singh sir and Professor Kapil sir, and I hope that the students will grasp the knowledge related to electric vehicle today, because the opportunities, all the opportunities don't come every day. So grab the opportunity and just clear your all queries, because electric vehicle is the most important area that is being growing day by day. As our Prime Minister Narendra Modi ji also said that the growth of EV is actually the starting of the silent revolution in India. And this is very much true, because we all know that in almost all the metropolitan cities, the main cause, the most important cause of the pollution, the air pollution, is just because of the road vehicles. And the smoke coming out from these road vehicles that is spreading throughout the air. And the research shows that this air pollution contributes more than 50% part of the entire pollution. So pollution is the major important reason to get into the market of the electric vehicle. And not only the pollution, the second main important cause is economy. So, as our government is taking a step towards the economy of India, so Prime Minister has emphasized that by 2030, India's economy would cut the intensity of greenhouse gas emission by 45% of what it was in 2005. Also, the data available in NITI Aayog database that is forecasting that by year 2030, almost 80% of two-wheelers and three-wheelers, 40% of buses, and 30 to 70% of cars will run on electricity. So that is the database available in NITI Aayog database. Also by year 2030, because of this transition of India towards the mobility of electricity, we will save around 20 lakh crore rupees in India just because of the import of oil. So economy is also the major point of concern to get into the market of electric vehicle. So because of these reasons, the government is also going to help the EV buyers. Some kind of incentives are providing by the government to EV buyers, like the loan. EV loans are provided at very low rate of interest. Very lowest GST is providing to EV buyers, and also rebate in the interest income tax rebate is also providing as for the ED buyers. So the database is also staying in Vahan. Vahan, you know, that is the digital registration portal for the vehicles in India. That is Vahan. So the data available in Vahan also shows that in India, in 2022, during the first 6 months, the sale of the electric vehicle has been tripled, right? So till the June 2022, from January till June 2022, around 4,445 electric cars has been sold in India, and also around 7,475 two-wheelers have been registered to be sold in Vahan. So, and that database has been proved to be 547% more than that is actually in the last year of the same time. So you can see that how the graph of electric vehicle is rising day by day. So you can think about it because you all are becoming technocrats. आप हमारा फ्यूचर है फ्यूचर टेक्नोक्रेट so you can just set your goal towards this field you can set your career towards this field you can think about it right now because this is the most growing field right now and you have set the future along this path and on the behalf of electrical engineering department on the behalf of faculty of engineering on the behalf of university I Dr. Karima Goswami I assure you that we will provide you all that support related to knowledge, related to finance, related to everything. If you want to enhance, if you want to go further along this area, whether it is research or it is project or it is any innovative ideas, if you want to go, we are with you, right? So for this, we have taken a step along this. We have included three papers, course papers related to electric vehicle and one lab of electric vehicle in our curriculum also. So that are the compulsory subjects for you. And apart from this, time to time we will be organizing such kind of events like workshops, seminar, guest lectures, industrial visit in EV area. So you can enhance your knowledge and if you want to do something, we are here to help you. So by these words, I am stopping myself because this is not my platform. Today is the day of both the eminent speakers, and I hope that after the day, the end of the day, you will grasp the knowledge and you will enhance some innovative ideas related to electric vehicle. So all the best wishes. Thank you.
Thank you, ma'am, for your valuable inputs. Now, I request Professor R. Trivedi, sir, the principal of FOECS, to come on this stage and enlighten us with his motivational words.
Thank you, respected Professor Muftiar Singh sir, Professor and Head Department of Electrical Engineering, Delhi Technological University, Delhi. Our eminent resource person, Professor Kapil Sharma ji, Head of the Department of Information Technology, Delhi Technological University, Delhi. both eminent academicians are having forte of this domain, and we have conceptualized to organize this workshop almost 2 months earlier, but due to the scheduling issue, it has been delayed. But nevertheless, there I those time. So, friends, first of all, I would like to congratulate the Department of Electrical Engineering of Faculty of Engineering and Department of Computer Science and Engineering for organizing this useful workshop on future trends and innovation in electrical vehicles. This concept has already in the phase of implementation, as Dr. Garima has narrated. So, first request from my side to all the students: be attentive, take your pen and paper, and note down note down the threads shared by our domain experts. Second point, I request from all the faculty members that the concepts shared by sir and given a pathway for the implementation that must be carried forward in form of students' projects, in form of their lab assignments, so that we may get some kind of understanding. This is not only a work of two departments, electrical and computer science. This involves whole engineering fraternity, because design is the part of civil engineering, and maybe that have inclusion with architecture also. If I talk about the mechanics, mechanical engineering is involved. If I talk about the power, electrical engineering is involved. If I talk about the automation, then the role comes, if that automation is at device level, electronics engineering is involved. If the automation is involved at operational level, computer science department is involved, because artificial intelligence and machine learning approach, how we have to incorporate in this, because the innovation trend is like tagging of the things, then sensor will sense the tagged things, then shrinking, the role of material science and the mechanical engineers came, and then the thinking things come. So I said, if thinking things come, so either the hardware level thinking comes, or at the software level thinking things come. So this is the domain which involves all the engineering and technology domain for the collective work. And as Dr. Garima has narrated nicely, after in fact information technology trained, this is one of the domain which is having future, and you could realize, in fact we have started realizing, and this you will realize after 10 years, because ultimate objective of environment safety, and we are trying to organize a such kind of workshop to just spread the ongoing practices. In fact, you could see electric trains successfully run, giving a wonderful output, lot of fuel energy saved, and environment friendly as well. Similarly, the time has come for electric vehicle. Not only electric vehicles, in coming future we could see the flying cars as well. Because because in people are avoiding public transport. Once every individual is having their own vehicle, so those days are not far away when you could experience a flying car. There would be a lot of towers installed, your vehicle is connected, as I said, tagging, sensing and all. So since last 30-35 years, this innovation trend is pretty high. Earlier days, this innovation trend was not very high, but you could see how the technological advancement is going on. And definitely माँ सरस्वती की जो वंदना हुई उसमें पहला लाइन था जग सिरमौर बनाए भारत यावल विक्रम दे. So ultimately Indians have started thinking कि अब हमें अपना कुछ करना है. People are talking about आत्मनिर्भर भारत. And on that case, you are having a more time than us. तो हम अपनी लर्निंग तो ट्रांसफर कर ही रहे हैं. अभी सर से भी बात हुई तो 3 मिनट का इंटरेक्शन था मेरा, तो उसमें यही है लर्निंग, जो लर्निंग कंपोनेंट है, that whatever we have, we are transferring, and you have to explore it further to increment that knowledge. So this is all from my side, and my best wishes to all the students for happy learning. And as I given a note, ultimately this is not merely a forum to organize a workshop. These things having some value, and once we have takeaways and we may carry forward in terms of implementation, that will really give us a sense of satisfaction of organizing such kind of workshops and seminars. So with this, again, I would like to welcome Professor Mukhtiar Singh sir and Professor Kapil Sharma sir. Thank you very much. Jai Hind.
Thank you very much, sir, for your valuable information regarding for being an ideal example of inspiration and motivation for all of us. Professor Mukhtiar Singh is working as a professor with the Department of Electrical Engineering, Delhi Technological University, Delhi. He has received the B.Tech and M.Tech degrees in Electrical Engineering from the National Institute of Technology, Kurukshetra, India, in 1999 and 2001, respectively. He has earned his PhD degree from Ecole Technologies Superior, University of Quebec, Montreal, Quebec, Canada in 2010. Professor Singh is the recipient of IEEE Student Scholarship for one of the best paper in 34th IEEE Conference of Industrial Electronic Society, the ICON 2008, held at Orlando, Florida, USA. He is also the winner of Researchers Merit Scholarship of the University of Quebec, Canada for 3 years consecutively, 2008, 2009, and 2010, for his excellent research work communicating to the PhD. Professor Singh is actively associated with IEEE and had been treasurer of IEEE PSEIES Delhi for chapter 2015 and 2016. He has also been the general chair of 5th and 6th IEEE Power Indian International Conference, PICON 2012 and PICON 2014. Professor Singh is also recipient of Research Excellence Award of DQ for the year of 2017, 2018, 2019, and 2020 and 2021. According to a survey, 2016 survey, conducted by the Council of Canadian Academics, He is an author of one of the top 1% most highly cited papers in your field worldwide. His area of research includes power electronics, power quality, renewable energy, and intelligent controllers. He is also in the technical advisor group of leading renewable energy companies like Uncon India Limited, Mainframe Solar, and have also been technical expert for PSUs like Coal India Limited and Power Grid Corporation of India Limited. He is also in the panel as a subject expert of TCS, which is one of the world's largest entities in the area of cloud-based IT solutions providers for the various industrial, academic institutions as well as the Government Examination Board. Professor Singh is also a university as well. Database professor Mukhya Singh has featured in the top 2% scientists in the world by securing 1867 rank in the area electrical and electronic engineering. So, as to enhance the objective of this session, we would like to call eminent speaker, Professor Mukhya Singh. Sir, now floor is yours.
Again, thank you, Dr. Rakesh Trivediji and Professor Garima Goswami and Professor Saxena at CC for inviting me and providing me the opportunity to interact with you guys. And I hope that since you are a mixed crowd from CC, EE, and IT also, electronics as well. So let me proceed like how I'm going to make this talk interactive to all of you. So I will start with the basics of in how we can go for different methods through which the electrical vehicle can be made more popular, and then how it can how it can get the maximum benefit out of it. I will start with the basics right from power electronic converters. Then, if time permits, then I will go for different kind of power electric topology as well. But I will also give you a brief introduction about that how the electric vehicle is normally have different building blocks and how they are going to work all together. So that is going to be the major part of this talk. So I'm going to start without wasting much time. So that's coming. So because you see that. There are introduction to power electronic circuits, concept of smart grid, electric vehicles. So some of part I can skip in between. I will give you a brief history of about the electric vehicles, advantages, challenges, and meeting the challenges. So these are the going to, and then of course the electric vehicles today, how they are going to be supposed to be here, and in future what kind of infrastructure support is required from government side also as well as from private side. So let's move to the quickly that why the power electronic circuits are required because in electric vehicle the energy is almost going to transfer in the form of electricity only from any source. Source may be a grid, it can be a solar panel, it can be even a fuel cell also, or it can be other means of energy through which the electricity can be transferred to battery. So because right now your IC based vehicles are having energy in the form of fossil fuel, means gas, gasoline or diesel. But ultimately, if you are willing to store some energy in the vehicle, that is coming only in the form of battery energy storage system, or it can be fuel cell also, where continuous hydrogen and oxygen need to be supplied to the fuel cell, and it is again going to give you electricity, and that electricity is going to drive the powertrain or the motor, which is of course required to run the vehicle. So these are the basic concepts of power electronics very much required. So I'm going to give you that there are fixed AC and DC supply, but to rotate a machine or to rotate any device, you need to have a regulated voltage, regulated current to be fed at the terminals of the machine or motor according to the requirement. So the way you are accelerating a vehicle, you need more energy to be transferred from battery to vehicle. So at that time, the opening of valve. So opening of valve, nothing, it is a flow of current actually. More pressure or more energy requirement is there, that means you have to apply more current, and that current can be applied to power electric device. So that is a valve. Just like in a IC engine you are having 4 valves, 6 valves, 12 valves, depending on that. So accordingly, that current is going to be injected through power electronic circuits only. So you need to have continuous sensing also, and then according to that you need to keep on calculating how much current, how much volt power need to be injected continuously in order to operate your vehicle at your desired speed or desired target, you can say, or desired torque also. Because not only the speed, sometimes torque is also a important factor. So, so these are the different on-off switching devices are there. So ideally the switches must be lossless. So when it is totally switched on, the current must be maximum and voltage must be zero. And when it is switched off, the voltage must be maximum and current must be zero. So on the both the condition, on off condition, if we multiply voltage and current, it comes out to power. So in both the switch cases, it should be equal to zero. So it is a ideal switch. You can say there are different diodes, thyristor, diode, IGBT, power MOSFETs, and then filtering equipment like inductor, capacitor, or high frequency transformer may also be required, because these are the building blocks of any power electronic circuits, and any circuits where the energy need to be processed from AC to DC, DC to AC, or any AC to AC or DC to DC, depending on voltage magnification or frequency magnification. So this is the whole circuitry which is there, and you need to have all inductor, capacitor, switch, IPO transformer, and switches, which makes it complete power electronic circuits. And ideally, these must be lossless. So this is the what is the expected power, expectation from power electronic circuits. And for on top of that, you need to have the machines which need to be there to control electric vehicle. So depending on which kind of power integrated modules or integrated power modules are required to control it, and then you can have ASICs, application specific ICs, FPGA, DSP, or microcontroller. These are the brains. Actually, brain is required to control the whole process. So coming to this part, I'm just going to give you the idea of why the power electronics is getting more popularity because of domestic and commercial applications, industrial applications, telecommunication, transportation, electric vehicle, generation, transfer, and distribution of electric energy, and implementation of Internet of Things. So you know that the power electronics is coming in a big way in every aspect of our day-to-day requirement, right from power generation, distribution, transmission, then utilization, and then further for connecting the different devices to internet or whatever means may be there. So that is the major way of utilizing power electronics. So coming to that part, so power electronic devices can be in capacity of less than 1 watt, and it can reach up to gigawatt size depending on whether you are using your wristwatch through solar plants, or you are using your pacemaker or some other devices. But you can also have DC transmission through power circuits only. So this is the rating kind of the thing. So you can have kilowatt to megawatt drives also, from right from running a e-rickshaw or just even a scooter to big train, or even now the automobile or that planes are also, all these are running through power electronic devices only. Here the power electronic converters are there to develop the power as per the requirement. So hundreds of megawatts in this transmission line. This is also big examples I am giving you. So I am going to skip this part and straight forward coming to that. Uh, I can say yes. So this will be more interesting. So in near future, actually, this slide shows that what kind of lifestyle it would be going to happen in near future. You guys may purchase electric vehicle. You may have internet controlled devices from appliances. You may have your solar power plant installed over there. You may also have some wind turbine, small capacity wind turbine to be installed over there. And then you, on the top of it, your every device is connected through or to each other through internet. So IoT, solar, renewable energy, electric vehicle, smart appliances, all those things are going to be there, and your whole energy requirement is going to be taken care by these smart devices. So normally, if I say, if let us say as a consumer, I'm looking to go for my energy security, and energy security comes from right now it is in the hands of either so. So the energy security comes right from where? Right now, if you are looking for your energy demand, it is coming from state electricity boards or some company, private company which is giving the power. But later on, so otherwise, if you are connected to a remote location where no electricity transmission is there and you need to have energy from other means, then you need to have diesel set. Diesel set is, it's depending on diesel and very polluted kind of device, so you need to have further solar panel or any other means of electricity generation where initial cost may be there, but ultimately you can generate electricity free of cost on long duration basis. A solar panel has a lifespan of 25 years, so it can keep on generating electricity for 25 years free of cost. Of course, the initial investment must be there, but after some time it is going to be there. So nowadays, the electric vehicle which is having battery inside it, so what you can do that you can generate electricity from the solar panel, you can generate the consuming. But if sun is only available during the night or daytime only, and during night time you must have a sufficient backup. And that backup, for that backup you use a battery. So we don't need to have installation of regular battery. What we can do that whatever battery is installed inside the electric vehicle, that same battery can utilize for charging or for meeting your load demand, because you can connect your electric vehicle through charger to the home grid network. So that means the charger must be bidirectional. Means it should not only take the power from solar panel to the vehicles, but when it is required, then that is going to transfer from vehicle to your home also. So in both ways, so what you are happening like when I was doing some postdoc assignment at MIT Boston, we came to know that there was a survey on which it has been defined that almost all the passenger vehicles they are running only for 2 hours maximum throughout the day. So rest of the 22 hours they are freely available. There are either standing at your home parking or office parking or some commercial parking. Otherwise, only 22 out of 22 hours, only 2 hours they are on road. So rest of the 2 hours are available on which your battery bank or rolling batteries which are installed in your electric vehicle can be applied for that purpose. So that was the major crux. So electric vehicle can also be very important in mitigating the fluctuations from renewable. Means renewables, no, it's not a controlled kind of power generation that you can do from thermal or gas power system. Here we can generate power as per our requirement. But when we are having power generation from renewables, the energy is always uncontrolled because it is dependent on weather conditions. The wind turbine is going to generate power when wind is there or not there. Similarly, the solar power is going to be generated only when the solar is available. Otherwise, during night or overcast condition or rainy season, no electricity is going to be generated. So that is so that kind of uncertainty which solar or renewable energy sources poses, that under uncertainty can be mitigated with the help of electric vehicles, because the battery installed inside the electric vehicle can store the energy when surplus power is available, and they can give the energy back to the system when less power or no power from renewable is available. So the electric vehicle can play all these roles very effectively. So coming to that part, so you can see that here you are having that wind turbine here. You are having solar panel installed over here. Then you are having internet devices, smart fridge, dishwasher, any other electronic device, and then through internet, everything is connected. So you can have sufficient power generated from solar and wind, and it can be supplied to vehicle also. It can be supplied to this one and this one. And then again, if you are generating more power, then it can be sent to the grid. And similarly, when you are not having any power being generated from there, then what you can do, you can also take the power from grid to all your home automation network. So, means IoT is there, intelligent electronic devices are required to take the data in real time from different appliances, and then they can send it to the cloud, and there through internet it can be sent to the mobile or any other remote location through which you can switch on your AC, lighting loads, any other device which is there. So detachable loads are there because the energy management required by smart thing. So all the things are going to be done in real time by the smart devices, and in that way you can you can better utilize the power energy coming from renewables without having much headache regarding uncertainty of the supply. So all the things are possible with the help of the systems which are there, just like you need to have the capability where the power can be sent to the grid or power can be taken from the grid. So B2G operation required. Then vehicle to load, if you are going with your vehicle to some remote location, can be possible. You can have smart illumination and all those things can be done with the help of that vehicle only. So vehicle to load is possible. Smart charging stations are required where wireless charging or through dedicated public utility power charging stations or swapping of battery. All the things are there. Then vehicle to vehicle, sometimes there may be possibility that one if you are running in a group or your vehicle is standing without you are having sufficient energy but you are not using it. So you can also supply the power to another vehicle which is in need of energy at that time. So vehicle to vehicle is also possible, vehicle to home. So all those things, when this kind of possibility is there in the future, then you can take maximum benefit out of your vehicle. Your electric vehicle is now going to act as a powerhouse. It is going to supply all your domestic needs without any, and at the same time, it is also absorbing power from neighbors very effectively. It is utilizing them very effectively. So all those things are then going to be very important in future. So if you are having a utility scale solar power of that renewable energy, then all that renewable energy can be generated at remote location, and then it can be sent to the load center to personalized network. So what is the crux? Sometimes the question arises that people say that IC engine pollutes, it is create lot of pollution because you are burning the diesel and petroleum. But there is also question that to generate electricity also we are having thermal power generation or major because 70% of electricity is coming from coal burning. So it is also creating pollution. So electricity is not also cheaply available. So now the question arises that why we are having electricity from solar, from thermal energy, which is creating again a pollution. You can generate electricity from electric vehicle from solar or any best possible renewable at that location. So to promote the renewable energy through electric vehicle is also one of the major issues these days, and people are adopting this technology very fast. And in future, you will see that every household is going to have their dedicated solar panel and their electric vehicle, and their normal household needs of electricity can be met by themselves and without having any connection to the main grid. So they are having different advantage also. So I am not going to go in that detail. Straightforward coming to that. So you need to have all those things, internet devices, and you can say that smart devices and the coming the power system network. Only then the system is going to do but more protected. So now coming to that electric vehicle part. So electric vehicle is coming in a big way, and you know that as already Professor Garima has introduced that the government of India has lot of very stiff target to achieve almost 50% of their vehicle, passenger vehicle at least they must be fueled by electricity only by 2030. And only constraint in popularization of electric vehicle the range, the mileage, because the energy storage which is required to store the energy, a lot of cost is involved in the electric battery itself. Nowadays, lithium ion batteries are there, and lithium ion batteries normally lithium magnet cobalt energy. They were supposed to be very, you can say, costly. And there is one incident happened with the Tesla vehicle that it got some fire. So that has again given a headache to the major electric vehicle players. So now a battery is also coming, which is known as lithium iron phosphate. LFP batteries are coming, which are supposed to be 99% fireproof. So they are also coming in big way. But only issue the cost. And unfortunately, in India, lithium is not available. Of top much grade lithium is not available. So that is also one of the issue. So definitely we have to go for some other means of storing energy. So aluminum batteries also coming in future, pouch batteries also coming in future, which are so aluminum is we are having huge resources. So definitely not only electrical engineer, it is as a totally electrical, totally engineering problem that you must have to think about different material sciences, material science, basic science, where how you can store the energy in big way so that it can be applied effectively later on. Nowadays, electricity is being generated in real time and it is going to continue in real time from the transmission line generation and distribution network. But in future, you have to you must have some means to store it. So electric vehicle is also autonomous power plant actually. Here it is going to take energy instantly from some charging station and then it is going to give power to its powertrain, or when it is being idle at your parking or any other place, then it can keep on energizing the remaining power system network also. So that is the requirement, and electric vehicles are, they are going to be there in future very quickly. So road transport and everywhere the electric is playing very vital role because of the carbon dioxide emission by different types of fuels we are currently using for meeting our transportation challenges. So EV power requirements. So right now, for 10 million electric vehicles are already in operation, and they just consume 3.2% of total power generation capacity worldwide. So means if we are generating 100 units, so only 3.2 units are going to be utilized for transportation purpose, which is very low share. In future, it can go up to 10%, and the pace at which we are the popularity of electric vehicles, especially the two-wheeler market, has emerged very rapidly during the last couple of years in India. So in future, the mass transportation can be coming through the electric vehicle only. So that energy consumption means electricity is going to be utilized only for illumination purpose, for air conditioning, for industrial processes and all those things. But now, in future, you can see that more electricity demand is coming from the electric vehicle also. And to meet that energy demand, you need to have dedicated charger, electrical charger also required. Those kind of challenges are going to be there. So normally the you can say that battery is the one of the major thing, and you need to have fast charging requirement. Solid state and lithium ion batteries need to be there, and low and high voltage system means motors like brushless DC motor, permanent magnetic motor, or they can be cooled, liquid cooled kind of motors. Charging voltage range is there, and slow charging, fast charging, battery swapping. All these are the kind of possible arrangements can be seen in near future to fuel, because you know that charging a battery itself takes a long time. Just like if you are in normal IC engine, you are going to a petrol pump and you get refuel your tank within a couple of minutes. But the same thing is not possible with the help of battery. But charge a battery takes a lot of time. But nowadays, fast chargers are coming which can charge up to 80% of your total rating within 30 to 15 minutes. But still, 30 to 15 minutes is a huge time. You cannot get for that much time period. So what we do that you can charge your vehicle in the night time at your home throughout the 8 or 10 hours it can get charged and then later on you can utilize for running purpose. But in future you can also adapt to the new technology. You can redefine your targets here. You can redefine your you can say travel period and you can recalibrate all the things. So you can do all these things. So electric vehicles were already available in market. It is not like that it is very recent. Electric vehicle always coming in locomotive, trains. They were having electric trains, water parks, forklifts, buses, nuclear submarines, elevators, all those are having, they are having motors inside, and those motors are already driven by battery. So it is only the now when we are talking about electric vehicle, we are talking about the passenger vehicle, passenger cars or even for road transport buses, mass transport buses. So these are the only things which are now coming to the picture. Otherwise, from generations we are already using electricity for transportation purpose, but for mass transportation or for transportation where the noise and other things are major problem. So in airports, forklifts are there, in godowns are there are so forklifts. So all those operations are there already existing with the airport electric vehicles. So now kinds of electric cars we are having hydrogen fuel cells, solar pelleters, hybrid, neighborhood electric car is also coming. And there are also MIT in MIT Boston there was city cars actually. And for inside transportation of the because the Boston they are having almost 5 6 big universities Stanford, MIT and that means 5 6 university big campuses are there and you need to travel from one place to another place through electronics only. That was the one of the thing. So coming to the history of EV, so history is if we go back like to 1830, the very first electric vehicle was there, battery electric vehicle invented by Thomas Davenport and Robert Anderson, others using non-rechargeable batteries. They cannot be recharged. So disposable battery at that time. And Davenport's car hold all vehicle land speed was until 1900. So you can the maximum speed was there by the Davenport only. By 1890, EV outsold gas cars 10 to 1. Means the EVs were more popular in comparison to petrol or diesel fuel car. So now history repeats itself. So now again the same thing is going to come again. Again, the electric vehicle are going to be more popular than this one. So, Oldsmobile and Stud Baker started an EV company, and in 1904, first speeding ticket issued to driver of an electric vehicle. Ticketing means challan, high speed challan for electric vehicle. So it was the history that how it evolved. And in 1910, mass produced Ford car undercut and built EVs. So Ford was the very first company which had produced the electric vehicle on large scale for commercial population, and then it became very popular later on. So EV persisted as a status symbol and utility vehicle until Great Depression. So means when there was a popularity of IC engine came into picture. Before that, the EV vehicle was there. It was you can say status symbol, just like iPhone these days. If you are having mobile, normal mobile, and you are having iPhone, so if somebody carrying iPhone, definitely it is a status symbol nowadays. So coming to the electric vehicle, how which kind of electric vehicles are there in market? So in normal conventional system, you are having a fuel tank here. The energy or fuel is injected to the engine, given to engine, and engine is connected to your transmission gearbox and all the things, so it is running your wheels, front wheel or rear wheel, or it can be four-wheel drive. So power from means energy stored inside the tank in the form of diesel or petrol. It is converted to mechanical energy through ice engine, and then that mechanical energy is going to rotate the wheels as per your requirement. So that is your conventional vehicle. But now a hybrid vehicles are coming. If you are aware, some of those who are from those who are very enthusiastic about the electric vehicles, you might heard about strong hybrid vehicles coming from Toyota. Toyota Hyryder is there. Suzuki has also borrowed the same technology from Toyota, and it is coming in the Grand Vitara, Suzuki Grand Vitara. They are having strong hybrid vehicles. Means some of the part will be supplied from conventional base, just like a fuel and the object and other things. And some of the part is coming from a battery, motor, and transmission. So both kind of technology from electrical as well as IC engine are going to fuel their energy demand. So why this hybrid, and this car gives you mileage almost 27 km per liter, and basically it is known as city car. Why? In city you are driving cycle, sometimes we are going at speed and suddenly you are braking again, high speed braking, speed and braking. So that means during the braking you are dissipating a lot of energy in the form of heat. So in city driving cycle, if you have an option where the daily braking, the power can be fed back to the brake, from this shaft to battery. Regenerative braking. We call it regenerative braking. While braking, while you are releasing the speed, the energy instead of getting wasted inside the braking or hitting of the tire or all those things, it should be diverted back to the battery itself. So discharging of electric battery is going to enhance the efficiency of the machine, because lesser stress will come from the fuel cell. Because whatever energy coming from the fuel cell, it cannot be sent back to the tank battery. Mechanical energy cannot be sent back to the in the form of petrol or diesel back to the storage tank. But mechanical energy can be easily converted into electricity, or electricity to mechanical energy. So electromechanical energy conversion is very easily possible, and that's why the small battery backup is also there, which can feed your energy demand. And now fully plug-in hybrid electric vehicle, we call it plug-in hybrid electric vehicle, where there is no fuel cell, no such kind of assembly is there, only a battery, motor, and transformer. So power can go to display or during braking period, or when you are braking, the power can also go towards the battery. So in that way, the efficiency of the vehicle is going to be much more, and it is going to be very useful. It is very. If some of you have experienced that e-scooty or e-rickshaw, you can imagine there is no noise coming out from there, and it is very rapid because the time constant. If some of you people are from mechanical or electronics or electrical, they can easily have a time constant. Inertia. The moment I switch a button, it is electrical circuit. The supply is connected to the fan at the same moment. But fan is an electromechanical device. It will pick up the rated speed according to the applied voltage after some time. So there is time difference between mechanical system and electrical system. And similarly, when I am going to switch off the supply, the electricity has been suddenly cut off, but the fan has not come to standstill immediately. It will take again some time. So the time constant difference is there. So in case of electrical energy, when in case of IC engine, when you are putting your throttle, the engine the controller need to send a command to the fuel valve. Just open the fuel, more fuel need to inject into the engine, and it is going to draw power, and then again it is going to come back. So it can give you desired speed. But in that whole process of time is consumed. But in electric system, if the moment you are pressing your throttle, the electricity can be supplied from your charge controller, electric drive or control system, from battery to your motor. So that is much faster. The performance of electric vehicle is much faster compared to your conventional IC engine system. So these are the some advantages. Now coming to pure electrical part, electrification, that how it works. So you are having a engine, you are having a battery, and the sometimes it can work only on electric. The through clutch, your engine can be activated from the main powertrain of the system. So through only electric, you can have both hybrid operation from electricity and from engine as well. This is required when you are climbing a hill. More effort, more power is required at that time. So both engine as well as the energy stored inside the electric vehicle, they can meet the energy demand. So IC engine de-rating has been done with the help of electric vehicle. De-rating means small size engine in combination with the battery can get the desired performance from the vehicle. In compared to that, you need to have 200 horsepower engine or 320 horsepower engine. That is not required. Small scale IC engine plus battery, they can meet your demand. And similarly, only battery charging means your vehicle is running, but sometimes you are applying the brakes. So during braking period, the energy is not going to waste it in the terms of heat, but it is going to send back to the battery. So that is also one of the advantages. And regenerative braking is also going to be there. During starting from braking to coming to standstill. So during that period, the energy is going to transfer from your that axle to battery. So that is also one of the advantages. So you are having electric only vehicle, you can have hybrid electric assist possible, battery charging is also possible, and regenerative braking is also possible. So overall, the performance of vehicle, not in terms of efficiency, energy efficiency, cost, or all the things, but also in terms of performance. Performance means accelerating and decelerating period. That is also going to be much faster with the help of electric vehicle. So, what are the major components of electric vehicle? You see that you are having battery management system, you are having a control unit, you are having drivers clutch and clutch unit, drivers unit. Then you can have that kind of IC engine if required. It can be connected to traction motor. So everything is going to take place. So all this is a brain actually, the dashboard of your car. Here all the things can be installed. Rest of the part, if you are having IC engine or traction motor or battery and we have battery backup and a charger and you can connect to utility. You can connect over here as a two switch socket charging plug. So all those things are taking place automatically. So this is brain and this is your real power train. This one. So whole vehicle, this is physical system and this is some sort of mechanical brain actually. You are taking data in from different motor terminals or you can say outside conditions also. IoT enabled devices may be there. If it is an autonomous vehicle, you can have a proximity sensor. You can have other sensors which are looking for the vehicle to vehicle distance or the nearby geographical you can say know so that your vehicle can also run automatically. So all those things are there, but possible with the help of these things. But rest of the things are the part of the powertrain which is going to drive your vehicle. So the dotted lines, you know, that dotted lines indicates the software as well as small electronic circuit, right? Which can have sensors, which can have internet or something, or which can have ESP, FPGA, microcontroller, or whatever of these things here. So dotted lines are only visible, but those which are connected to dark lines, they are blue mechanism. So it is just like our human body actually. Human dark lines, they are blue mechanism. So it is just like our human body actually. Human body, if eye, nose, sensor, ear, all these are the sensors. Hands and legs or mouth, these are the actuators. Even this is the actuator. Actuator means which is acting on behalf of the instruction coming from the brain. We are sensing, we are touching something, it is hot or cold depending on that our skin is acting with a sensor. It is sensing, and then the signal sent over brain. Brain gives the command. I have to either move my hand from the surface or I have to keep a safe distance from there. So accordingly, I am taking the decision. So same thing in electric vehicle is required. You must have brain. So for operating brain, you must have a sensor. So sensor and sending data through IoT and then taking decision, and after taking decision, you have to execute the decision, and decision has to be executed through the actuator only. So actuator is nothing, it's a electric motor installed inside the machine motor, or you can say the charging or discharging of the battery means I need to stop the battery supplying power to the motor, or I have to supply more power depending on what kind of case is there. So accordingly, you can do the whole thing. So this is the one of the you can say overall know about the electric vehicle, that how it looks like actually. Otherwise, inside everything is same, just like conventional IC engine based electric vehicle. It depends whether we are totally removing it, then it is totally electric vehicle. If we are keeping it, it is a hybrid vehicle. And if if there is no this one, then it is totally IC. So vehicle is from inside looks same, from outside looks same. Inside, depending on the powertrain topology, it can keep on changing. So now coming to the degree of hybridization, means up to how much extent we can make a conventional vehicle to an electrified vehicle. So if automatically start the engine in stop and go traffic, like nowadays in Delhi there is advisory, like since there is a lot of pollution and there air quality index is dipping very fast. So what the latest advisory is there, that you have to mandate to switch off your vehicle at the light. So on off, continuous on off switch off in the vehicle is required. So that kind of when your vehicle is going to stop more than that, that can be done automatically with the help of battery installed inside the system. So ignition of the engine actually on off. So that is a micro hybrid, where only the features of automatic on off is inbuilt through the battery. So that is your micro hybrid, and that is Citron C3 is having that facility. Then mild hybrid which is also having huge regenerative braking and operates above 60 volt and uses an electric motor to assist a combustion engine. So that is a mild hybrid. All those three features are inbuilt inside that vehicle, so that is a mild hybrid. Now coming to full hybrid. Full hybrid means now extra part has been included, means that it can drive at times using only an electric motor. So up to certain distance, the vehicle can be operated only on the battery cell without using engine. So if that feature is there, then it is a full hybrid. So that Suzuki Grand Vitara, strong hybrid, or Toyota Highlander, and now Innova Hycross is also coming based on the same performance. Toyota Prius is already there in the market, which is operating on the same principle, hybrid engine, which is having the same kind of possibility. But if you are having further, plug-in hybrid means it can recharge batteries from a wall outlet or extended all electric range. So before that, this part, the vehicle was going to be charged by it was going to be charged by the engine inside the vehicle. But the last part for this vehicle, the additional feature is this one. This is there where the energy is going to be transferred from wall-mounted charging station. Otherwise, before that, all those vehicles they were having the charging was taking place within the vehicle itself, without having any external means of charging it through electric network. So that is the difference. Are you getting it? So micro hybrid, mild hybrid, or full hybrid. Here the power source is only engine. But in case of plug-in hybrid vehicle, the additional feature is there where the energy is going to be supplied from the outside charging station. So that is the major difference. So now coming to energy loss or calculations. So urban drive cycles energy balance which has been conducted on 2005 on Tata Company and it got published also in our auto magazine. So they say that fuel tank, let us say we are talking about a conventional vehicle where the 100% energy is stored inside the fuel tank. Then through engine, standby losses are 8% and engine losses are 76%. So only 16% of electric power which was stored in the form of fuel inside the tank was available up to only 16%. And from that 16%, some losses are going to take place in the drive train, means gearbox and clutch arrangement. So 3% power is further lost over there. So only 13% power includes sense is available to drive the wheels. So you can say that 87% power has been lost within the system itself. So that kind of thing could be avoided. So further you can say that out of that aerodynamic losses are 3%. The big high racing cars, they are very aerodynamic in shape. Rolling vehicles, they are also having friction losses. So 4% is going to loss. And braking, 6% losses in braking. So in that case, that how the whole power coming from the fuel tank has been converted to different forms of losses or fuel energy in that way. So that is the case of city driving. So in city driving, why the mileage is poor? Because losses are more. So where we can save on? We can save on, let us say, now coming to highway driving. In highway driving, 100% fuel tank, 0% standby losses. In city condition, it was 8%. Now the 0% is going to be studying. Engine losses are 77%. In previous case, it was 76% because at high speed, the engine is operating in front of it, so a lot of heat is generating. So it is also its efficiency is going down by 1%. So 77%, but 23% power is available to drive train, which was earlier 16% only. So out of 23%, now 4% drive lashes, 90% power is available, and 10% power is lost to aerodynamics. At high speed, the wind is going to oppose the flow or you can say the movement of vehicle. So 10% losses are going to be aerodynamics, 7% rolling, and 2% braking because there is no braking at all. Only minor braking sometimes, some instantly some vehicle is coming or something like that. Only then it is required. Otherwise, so that is the true sense in which the electric vehicle performance can be evaluated on highway basis on the city driving basis. So now coming to that part where we can save on, we can save on this micro hybrid elimination, standby losses. Those standby losses can be eliminated by having micro hybrid push on off, automatic on off facility through battery. Then we can switch off save on braking also, 6% braking because we can take the power within the battery system. Regenerated braking. So 16% coming from there. And then the major culprit is engine losses, where the efficiency is 76%. 76% losses are going to be there. So engine downside means you can say 76% plus 6% plus 8%. This roughly comes out to be 90%. So 90% of there is a scope of saving 90% of roughly comes out to be 90%. So 90% of there is a scope of saving 90% of energy if we are going to have electric vehicle. So that is we can for the same kind of performance for the same vehicle we can downsize the size of the machine. So So that's why the 23 to 30 kilowatt hour battery backup is equivalent to almost 120 horsepower engine in Tata Nexon. If you go for Tata Nexon vehicle, the specification, you see that it is 100 to 120 horsepower normal IC engine. But when it is coming to electrical, they are only having 23 to 30 kilowatt hour backup. So one third downsizing is done. The decoupling of engine and wheel is possible and can eliminate engine entirely. So that is a major scope where we can save the energy through electric means. So now coming to battery. So battery is, let us say battery is having 100%. Then there is no motor. There is no engine. It is a motor. So motor losses are 10%. Of course, motors are having some losses. So 90% of energy coming from the battery is available to the drivetrain. And again, the same losses, 76 or 40% losses in drivetrain. You are having 76% energy available for the electric vehicle, and out of that, 29% is going to go for aerodynamic losses, 35% for cooling, and 11% for braking. So this is the in true sense, that how this major calculation based on IC engine and electric vehicle engine can be done, and it's really very beneficial. We can downsize that. It only major challenge is in storing the energy, where with the compact size battery and more range and fast charging. Charging time must be reduced actually. So that is the major research scope for the electric vehicle. So now coming to well to wheel efficiency. So when we compare that, okay, electricity is also being generated through some means, and the engine that generated through some means, and the engine that refinery or through which it is coming, it is also some means. So we are comparing fuel station right here. Vehicle is here, it is being fed through gasoline, but including some refining process and all the things, tanking and all the things is available. And in this process, more burning fuel, grid electricity, then metering, and then this one. So we are concerned about that how the electricity is being or how the fuel is being supplied at the doorstep of electric vehicle. So let us compare this strategy also. So now coming to this comparison, let us say you are having generation through thermal power generation, its efficiency 33%, very poor efficiency. Then transmission efficiency is 94%. 6% losses are going to take place in the transmission line network. Then plug to wheel efficiency we have already calculated by 76%, right? So if you multiply 33, 94, 76, it comes out to 23%. 0.33, 0.94, and 0.76. It comes out to 23%. Right? Now, if I go for refining process, the efficiency is 82%. It's more efficient than thermal energy conversion. But transmission efficiency, because the fuel is going to transit through pipelines or through tankers. So 2% loss in evaporation losses are definitely there. 98% efficiency is there. So 80% is available there, but engine is having very poor efficiency. Only 16% vehicle is there. So the net is coming out to 30%. So still I can say my electric vehicle right from generating to giving power to the electric vehicle, the electric vehicle is still 10% higher efficient than your conventional IC system. So that is also one of the major advantage. So 10 to wheel, you can say that 10 to wheel efficiency is 23% and here it is 30%. So let us say, but I think how much time you have to be? I can take another half an hour. Okay. So So coming to the benefits, so state of charge, depth of discharge, capacity, energy, specific power, all these are from the standard terms, which are related to battery. So benefit of EVs and PHEVs, so more efficient, lower fuel cost, lower emissions, simpler transmission, fewer moving parts, fuel choice. Oil fuel choice means you can take from solar, you can take from wind, you can take from fuel cell. You can take from solar thermal power generation. You can take from diesel generation. So fuel option is here. So oil and fossil energy independence, emission improve with the time, and emissions at few large locations is easier to control than millions of dead fires. So all these other things. So vehicle to grid is going to give a much better option. So there allows communication between utility and vehicle. Utility means the utility board, supply board, electricity board. Allow integration of more renewable lights, green use the EV batteries could be used as a stationary battery for utility. With so much focus on energy efficiency, reducing electricity sales and expensive renewable energy generation mandated, EVs could be a welcome new segment for utility, and they could still be a nightmare, and battery could be provide more ancillary services. So operating cost, coming to the operating cost part, you see that on-board energy consumption 190 watt hour per kilometer. If charging efficiency 19%, electricity consumption comes out with 210 watt hour per kilometer, and let us say standard cost of electricity 5 rupees per unit. Then driving a electric vehicle, the rate comes out to be roughly 1 rupees per kilometer. But if you compare a fuel economy in terms of a vehicle which is giving 15 kilometers per liter as average, and fuel cost I have taken 75 rupees. It was 2 years back. So the driving cost is coming out to be 5 rupees. So you can say that the efficiency or cost saving and other benefit in terms of less pollution and modular nature, all these benefits are going to be very multiplied in compared to your system. So challenges are there. One current challenge, so you can say CO2 emission, emitted well to wheel. So electric car only generate 10.6 kilogram carbon dioxide compared to a Toyota Prius which is hybrid, which generate almost 26.3 kilogram carbon dioxide, and Pontiac Grand Prix, which is a purely ICE engine vehicle, which generate almost 61.8 kilogram pollution carbon dioxide. So it is almost 6 times safer in terms of pollution. Now other benefits, let's say gasoline, the almost perfect fuel in terms of storage, because volumetric efficiency of weight is much compact, it is much compact. So one gasoline, it has 135 megajoule energy content. But one gasoline, just like that much, one thermos, 2 3 kilogram, 4 kilogram thermos or cylinder. So 3.6 kilogram only. But battery size almost 340 kilogram. It appears like to have a supply from fuel tank of 4 liters, almost 10 times of weight. Not only weight, but volume. Volume is also going to increase. So that is a major drawback with the electric vehicles, that the battery size, packing a battery within a vehicle is a great challenge. And it always there that the 340 kilogram it means almost if we consider standard weight of 60 kilogram, 6 passengers are already sitting in the vehicle. The battery weight is too high, 340 kilogram, which is almost equal to 6 passengers are already sitting in there. So that is one of the drawback. So 340 kilogram, and it gives you 54 gallon, means in terms of volume. In terms of volume also, 1 gallon gives you 54 gallon equivalent. So 54 times volume is required. So these are the challenges. Limited range, large battery weight, size, long charge time, high initial cost, battery life, consumer acceptance, because still it is not popular because of the issue and grid integration. So we have to address all those things. So then how we can meet those challenges? First by swapping of the battery. We can have to do the time, we can have swapping of the battery. Uh, we can have some other plants also where we can have dedicated charging stations in commercial building, office or homes or parking spaces where the proper planning and coordination is required and accordingly we can manage all those things. Rapid charging is also one of the issues. So bicycle, it can have a back size of half kilowatt hour back size mobility chair and 1 kilowatt hour back size for 40 kilowatt, motorcycle 6 kilowatt hour. Four-wheel can be have 20 kilowatt hour back size. One standard sedan can have 30 kilowatt hour backpack, and big sedan having 200 miles range can have up to 60 kilowatt hour battery pack. So these are the different size of battery pack depending on kind of vehicle which we are going to have. So it can be there, and so you can have 120 kilowatt, 120 volt 50 ampere can be sufficient for this one, 220 volt 50 ampere for up to this one, 220 volt 200 for this one. But if we are going to so, but if you are having big sedan like this, the charging is going to have done on much commercial scale, 480 volt, 100 ampere, 1000 ampere current need to be injected. So 830 kilowatt custom design industrial charging station is required. So which is a big challenge. So charging a big vehicle in smaller time, that means you have to pump more current inside the vehicle within lesser time. So dedicated big current carrying conductors, power electric devices, and related power infrastructure is required actually. So that is the major difference in the popularity of the high performance, high capability in electric vehicles. So batteries are already there. Lithium-ion battery recycling is 90% recoverable possibility there. Battery cost is attached to that. And nowadays, battery cost is the major cost in an electric vehicle. It can go up to 5 lakhs to so adoption rate is also increasing day by day, and nowadays EVs are coming in the form of EV today. We are having different kind of EVs. Tesla is the most popular vehicle these days, and top range is 125 miles per hour top speed, and acceleration is 0 to 60 miles. एक ही दिन है ना So the vehicle which can have top speed up to 125 miles per hour, it's roughly comes out to almost so 200 kilometers per hour you can say it can go up to that. So 244 miles, almost 350 kilometers. Now 500 more than 500 kilometers range is there. So electrical infrastructure is required where transmission lines, it will be transformers, switchgear, switchboards, then we are submitting general purpose transformer, then we are in, load centers and chargers. So coming to this part, you see that this is the typical charger looks like that. You are having a 145 negative power and inspired by there. And battery just placed within the seat, covers will say vehicle seat cover, and there you are having drive tank. So the charging is taking place in that this case. And different kind of charger depending on slow, fast, and medium charger are there. Wall mounted charger there, 50 physical charger are there, and then small mounted station may also be there. So all these chargers are already available in market. Chargers have different ports and terminals. These kind of standard cat mode chargers are very popular in India right now. There are different kind of protocols actually. So these are the different key configurations. I'm not going to much detail of those things. So electrical charging it can be done conductive onboard and outboard also is through wire. You can have EV charging level 1 slow, level 2 fast, semi fast, and level 3 fast. Similarly, you can have electrical charging station depending on AC level or DC level. Normally, DC voltage level are fast chargers because they are more efficient, and that's why they are preferred. So coming to this, so EV charging stations looks like that, and you can have this kind of power electronic interface required where you can have dedicated DC bus and n number of vehicles could be connected to the charger depending on what kind of capability you are having. Because this is the current capacity. If n number of vehicle and every vehicle is tracked on the car and is current at the same time, so this all this infrastructure must be able to handle that much current. This must be the charger must be able to handle that much current in real time. So that is the big requirement. So the cost of equipment to be used as well as cost of operation. So I am not going to come to this now. So let's have a. So this is what a specific charging electric vehicle looks like. So you are having grade. You can have level 1 or level 2 charger. Level 1 is installed inside the vehicle. Level 2 is outside, and fast level 3 can be into the website. So these are the different chargers to be electricity to be supplied to your battery. So AC/DC filters, DC/DC converters, your battery, and then DC/AC converter, and then motor, and that's the power tank. So this is how your inside electric vehicle all the equipments are fitted inside. So power converter, motor, and battery. All these are the, so power converters can be onboard charger, back-to-back converter, offboard can also back-to-back converter, and it can be two-stage charger. Then you can have AC/DC boost converter, interleaved AC/DC boost converters, AC/DC multi-level chargers, symmetrical boost-dash boost converter, asymmetrical boost-dash boost converters. You can have half bridge, you can have full bridge, you can have 12 half bridge, depending on costing of the charger. If you save on the costing, you can choose the number of components, number of fast acting devices. You can have half bridge, 3 level diagram, fast DC charger, also is possible. And then you have half bridge converters, truck converters, one cascade half bridge converter, interleaved half bridge converters, circuit converters. So coming to that, wireless charging is also there, where the power can be transferred wirelessly from just like induction cooktop, you are supplying energy from induction cooktop to your vessel for cooking meals. So wireless is a issue, but in future you can have a circuit like this one, where two conduction coils are there, just like a transformer. That is going to transfer from one coil to another coil without any physical connection between them. So this is induction only, without any conduction. So that is possible. We are some major project people, some students who are doing in that case also wireless power transmission. So that is the typical wireless charging system. You have a power factor correction and inverter, then relevant transmitter, electron motor. So these are the four parts. These are installed inside the car, and these are stationary. So upper and lower seat. So 1, 2, 3 items are stationary. They are available outside, and 4, 5, 6 they are available within the vehicle. So in that way, the wireless charging is also possible. And some practical example like Tesla, BMW is having BMW I car the wireless charging system they are having. So this is the wireless charging station actually here. So vehicle need to come on the top of the induction plate, and then the energy is going to transfer wirelessly to the system. So matching relevant are some methodology which are required. So this is how the power flows actually from ball assembly to vehicle and vehicle to interface, and these are the wireless electric vehicle charging possible with the converter. So some topology of wireless charger are also there. Z-based full bridge converter, full bridgeless LIC converter, interleaved Z-based converters, on-board e-directional full bridge series resistance charger, isolated bidirectional or dual active bridge converters charger. Then you are having all those things. So coming to that part, dynamic charging is possible means the vehicle can be charged during motion. So on the road side you are having wireless power transmission is there, and the vehicle can get charged due to motion also there. So that is known as dynamic charging of electric vehicle. So that kind of feasibility is there. So this is the basic circuit actually, that how the below the road there is a some plates, and power circuit is there, and on the top of that the vehicle is moving and it keep on charging during the motion itself. It is still in for the elementary form only, because the technology itself is very costly and efficiency is also very poor. So this is the major drawback about in future. Just like pantograph, electric locomotive taking power while in motion through physical connection through electric pantograph. But in this case, it is taking power via the motion. So this is the wire dynamic charging infrastructure is there. So anyway, this is some research part which I am not going to discuss because it will be for better good for body to people. So really, I just try to throw so much information to all of the people because of the time constraint, and almost it's more than 300 gathering, and I am still appreciate that you guys, despite of having from different background, you have tried to come to remain calm for so long duration. So I really appreciate for your patience hearing. Thank you very much, and any questions, please share.
So recently, I get to know from the Tata industry, and they are launching an EV, that is Tiago Tigo, right? And they are Tata Tiago, Tata with the EV, okay. And they are saying that they are giving the warranty of the machine up to I think 10.5 years or 30 years. So, as my own opinion, that the EV, like we are using the EV in the market, e-rickshaw is there. They are getting very less real life. Like 1 year or 3 years, they are going to be run out, and then we need to change the particular part, we need to change the battery. So, is it possible that it will, in real, compensate the real problem, or will arise another problem? One, that's my question. And second one is, like we are dependent on the government right now to get the elements. We are dependent on the thermal power plant or hydro power plant or nuclear power plant. They are having certain disadvantages in terms of pollution, in terms of other things also. So by now, as we are polluting our air by the thermal power plant, so when we are going to use EV, a certain time of span they are going to be running. We need to replace them. We need to recycle them. So again, they are doing some more pollution in terms of soil pollution, or is it good or not? This is my question.
So let's coming to your first part as manufacture. So anyway, the very first part, the in case of electric vehicle, as the sir has pointed out that there is so many problems of water failure or lot of repair maintenance required because nowadays none of the manufacturer actually is manufacturing in India. In the name of Make in India, what we are doing, we are importing a cheap part from China and assembling over here. And the BLDC or BMS machines which are there inside the electric vehicles, the permanent magnet is the main part. If it got saturated by the passage of time, definitely it will be repaired or it has to be replaced. So the permanent magnet is not easily available in India. Still, 90% of PM permanent magnet resources are available in China only. So we are dependent on them for that purpose. So in future, if we are having SRS, synchronous reluctance machine, or hysteresis machine, or any other kind of machine which can replace permanent magnet permanently from the motor, then we can definitely look for that part. So that is coming to this part. On the top of it, the charge controller which we are having, they are also more pulsating in nature, more harmonic quality. So they are also derating the motor much faster. So that is also one of the reasons which we have to think about it. And China has not allowed more than 2.2 horsepower motors for electric rickshaws. But have you ever imagined why our e-rickshaw cannot move more than 20 to 30 km per hour? Because our motors are limited to 2 horsepower. Fortunately, the data from some outside alliance, they got up to 10 kilowatt motor inside it. So that's why they are able to pick up the speed. And Toyota Prius or Toyota Hilux or the Toyota Hyryder, they are almost having a 90 kilowatt of motor installed in the vehicle. So more rating, more performance, more speed is can achieve in future. So we are still in emerging phase. The things will settle down very quickly. Now coming to your second part, as you know that the electric vehicle is also taking power from the thermal power plant, and thermal power plants are polluting more pollution. They are creating more. So I okay. So they are creating more pollution. So what happens? At least we are shifting the pollution. Thermal power plants are installed in remote location or at outskirts of the city. So major road is in the city itself. So that, right now in Delhi, outside the region may be more better air quality index, but in the city the air quality index is very low, almost 500. So why at least we can shift the pollution? We can shift the pollution from metro city to the place where it doesn't not matter much because there are a lot of vegetation and green plant is there which can absorb the pollution more quickly. So that is how we can handle the crisis of pollution through thermal power generation. So vehicles are an important part where electricity can be generated anywhere else, but it can be transferred to the bulk power station, bulk power location like metro city. So the pollution in atmosphere can be shifted from the major city to some remote area where lot of vegetation, plantation, and forests are there, where they can take it as a food. Because carbon dioxide is also food for the plant. They can grow much faster than what they are doing. So in that way, I think I have addressed your question. Thank you. Yes, anybody else? Any other question, please? Yes. Electric vehicle.
Disadvantage of planet.
इलेक्ट्रिक व्हीकल का डिसएडवांटेज बताएं।
Electric vehicle का disadvantage, as I have already told that the battery energy storage is a big challenge. The size of battery, accommodating the battery within the vehicle itself is a big challenge. As I have already told you that 1 gallon, which is almost equal to 4 liter, that 4 liter fuel equivalent is equal to 340 kilogram. of 54 times much bigger in volume also. So volumetric and weight wise, the battery capacity is still a very big headache, and charging a battery in a lesser time, because if you go to petrol pump, you can get fuel of almost 200 liter within 1 minute. The power pump, the pumps are there, but you cannot transfer that much energy in a 1 minute. It's a 70 kilowatt hour battery backup is there, so you cannot charge 70 kilowatt hour battery within 1 minute, because hour is converted to minutes. Within 1 minute, 70 kilowatt into 60. 420 kilowatt minute. That cannot be charged, because if you divide further by 200 or 400 volt, the current comes into 1000, 1 lakh ampere cell. So no material is available which can absorb that much current instantly. So that is one of the disadvantages. Okay, any other?
सर जैसे आईसी जो व्हीकल्स होते हैं उसके अंदर हम अलग अलग स्पीड पे ट्रैवल कर सकते हैं, जैसे फर्स्ट गियर सेकंड गियर में, और जैसे हमें टॉर्क ज्यादा चाहिए और स्पीड कम चाहिए, तो देखिए इलेक्ट्रिकल व्हीकल में ऐसा पॉसिबल है?
Yes, yes. Electrical now in IC and automatic gearless system is there. Automatic. Same kind of transmission is there. In that case, you are just by controlling your throttle, you are just controlling the current instantly. So opening of valve is controlling the current through power electron device. So which is happening there automatically. So while you are pressing throttle or releasing the pressure, you are doing the same thing.
और जैसे एक्सीलेटर
Acceleration. Yes, please. Okay, I think I must leave some time for my break. He's also waiting since 2 hours. So, okay, change over to Professor Kapil Sharma. So,
Thank you, sir, for enlightening us with your kind words of wisdom. Professor Kapil Sharma is professor at the Department of Information Technology, Delhi Technological University, Delhi, India. He has completed doctor's degree in computer science and engineering under the Faculty of Engineering and Technology at the MD University, Rohtak, India. He has obtained his Bachelor of Engineering and Master of Technology degrees in Computer Science and Engineering and Information Technology. His areas of interest are artificial intelligence, optimization, evolutionary computation, software engineering, malware analysis, and many more. Sir handled DRDO-sponsored project on malware analysis. Especially computer science students will be sitting over here because this lecture is especially for you people. So all CS students, be seated over here.
Hello.
आप लोग CS के होना चलो.
Please settle down. All of you, please settle down. As you know, Professor Mukhyas has given a great lecture on EV. You know, when I say this EV, but why EV? because in EV or any vehicle we want to transport our bodies, not our mind. And it is true. But EV transports our bodies, not our mind. When I say this sentence means if you want to exchange your ideas, want to interact, you don't need EV, you don't need so much complex technology. If you want to transport your body, then it's required. Fine. The COVID has taught us to do the things virtually without traveling. Okay. So I am giving you some sort of technology on that. How to transfer your thoughts, not body. Okay. So as we all heard of machine learning, you know, which are the best machine, we'll tell you which is the best machine. Can anybody tell? Best machine till now. Computer. No. Your body. Your body is the best machine ever created. It is highly efficient in terms of energy and things. It create AI. Okay. So now you think we as a human have an island intellectuals, but you see how humans has come on this earth nearly 20,000, 50,000 years old. But you see all insects, they thrive crores of years. And they will thrive after being extinct. They are the real survivor on the earth. Insects. So we need to learn how insects work. Because we have to work on the AI. We want our computer to work like those insects. So the basic concept behind this learning, it is particle form optimization algorithm, how it get involved. Because bees, the population of bees is more than humans, and still they are growing. They control us. There was a research: if you kill all mosquitoes, you will die. If you kill all bacteria, then you will die. So these things are essential and they are integral parts. So we need to learn from them how they work. We have to gather the information. One more thing. When you go to the biological sphere, human is the only species when human comes into this world has no pre-programmed thoughts or code. While other like serpents, all other mammals have their code in their brain. What to do after birth? A human child do not know what to do after birth. He is on the mercy of his parents. But reptiles, they are not, they are pre-programmed creatures. They know what to do, how to break egg and came out, and what to eat. Nobody is going to support them. But for as a human, we are totally 100% helpless. Why? What is the difference? It is the code. Our brains are empty. We entirely thrive on the learning, not the fixed code. This is the important. The learning is the factor that separates human from all others. With the zero knowledge at birth, start learning and learning according to the environment. But all others have fixed coding, like these insects, they are almost same from the last thousand crores of years. But humans have changed, they have evolved due to this learning process. So we'll see what the secret of insect to be successful species on Earth. This is the important one. Let's start with this. Dr. Albert Kennedy in 1995 originated as a real life example, simplified social system. Human social system very complicated. So the intent, the graphical simulation of photography of birds, frogs, fish frog, how they behave. The fish are swimming without colliding themselves. They were like in such a state. When birds fly on sky, they do not collide each other. Why? They are in sync. So and what is the success? If you see the single fish and single bird will die out, but as a group, as a flock, they will survive. So what is the result? So if they studied how a group survive in the real world. So there are some keywords that I think might be using bird searching for food. Means every bird is looking for food for their survival. Searching for one piece follows bird nearest to the food. I will explain what it is. Only know how far food is. These are two metrics. They see food distance and who is grabbing more food. Okay. So analogy is particle, fitness, key best. I will explain this values, local best, global best. So these are the technical terms that I will be explaining in the coming slide. But before going to further, we will see an example, a cooperative example. Let me tell you, humans do not cooperate. They change their stand, depend on the situation. But animals do not do this. They always cooperate, whatever the condition. Why this is happening? Because they are coded like this. They have to do certain activity irrespective of environment. But human changes. So there is no human optimization algorithm. Remember. So let's see. The task is there is a code. The code is two-dimensional for easy one, otherwise it is a 3D one. So we have two dimension x and y axis. Code having a depth d. We have two depths d1 and d2. And the problem is to catch a fish. It's a simple problem. How to catch a fish. So the heuristic of metric is that fish hides in the deepest point of the pond. This is the knowledge or heuristic you can say. You have to catch a fish. So let's start. We take two fishermen at left and then right. Randomly we can place any fisherman at any position. This entire line is our search space. So for easiness, I will put fisherman in extreme ends, so we will search in opposite direction. So let's say fisherman left and right. Both are having a depth. This green line denotes the depth, and it is the metric to catch fish. What is the metric? If greater than, you will get fish. Chances of getting fish is greater. Okay. So now this is a step T for time T. D1 left and D1 right. Remember this step. You have to keep track of the record. Now let's see. This signifies cooperation. Both fishermen exchange their current depth. This is important thing. This is the example of cooperation. If we do not cooperate, then we are in isolation. We do not have the knowledge where we have to go. So this left hand side fishermen and right hand side fishermen, they cooperate and they exchange their depth. I consider this that they are equal. Consider them they are equal. So okay, no problem. They will proceed in the direction in which they are moving. That is called initial velocity. They are moving. Because that are cancel out. If I take a difference will be 0. L d1 minus L d2. Difference is 0. But after some time, because they are moving, they are not stationary, remember that changes. At step 2 or time t2, now they have different d2, L d2 and RD. Now they will exchange this information. This is called cooperation. They have to tell each other. Humans do not do this in their algorithm. If you find something, you won't tell others. This is the human behavior. But all insects do this. So they exchange their depth. Now you see the fisherman at the right hand side is at greater depth as compared to left hand side. Now you compare those depth. What that means? For fisherman at the right hand side, he is at a good position of getting food, greater depth. So fisherman at the left hand side will calculate the difference. Okay, that he is at greater depth, so he will start moving faster toward them. Now, what is the call? Come to my side. I am at greater depth. Okay, he will go definitely, no problem. But one more factor is this: if you see the fisherman at left hand side, it's personal. There are two positions of fisherman at left hand side. One is D1 and D2L. What it says, D1L and D2L, if you take the difference, the depth is increasing. Means the initial direction is correct of the fisherman at left hand side. And the same applies to the fisherman at the right hand side. This direction is also correct. Why? The initial depth D1 is lesser than D2 of the fisherman at the left hand side. Means what direction he was following was correct. These are the personal things. But what is the cooperation? Cooperation is the difference of the depth of the two fishermen. Okay? They are exchanging the information. So this is the, again they are saying, for fisherman at the right hand side, it is negative value. It won't follow the direction of fisherman on right hand side. So it is saying I am at a good position, I won't further proceed. But fisherman at the left hand side will proceed to the fisherman at the right hand side because it is at the greater depth. So this method will give you a direction and velocity. Now this is in interesting case. So the fisherman is at the left hand side. You see there is a D3. You know D3 is lesser than D2. For left hand fisherman, D3 is lesser than D2. That means he is moving in a direction where depth is decreasing. Where depth is decreasing. So if you take difference, he will say, oh, I am in the wrong direction. I should reverse my direction because my depth is decreasing as depth is. Its personal observation says like this. Clear? But problem is this is a local minima. He will never come out of this local minima. The depth where there is no fish. When he try to go to the more depth due to this decrease in depth, his velocity will decrease. So he will be trapped in this. But the cooperation. Now the second factor comes into the picture is cooperation. Because the fisherman at right hand side has given the information and its depth is more than D2. Its depth of the fisherman is greater than D2. So D1, D2, D3 of fisherman at the left hand side. So if we take a difference, though he will be moving toward the fisherman at the right hand side, but with lower velocity. He will come out of this local minima due to this cooperation. You have to remember this example. These examples will be translated to the equation. I will tell you. So due to this cooperation, this fisherman at the left hand side will move toward the fisherman at the right hand side, but with lower velocity because its personal difference L T2 minus L T1 is negative. So it will slowly move. Now after this, at step 4 you see, due to this cooperation, he came out of the local minima. Now you compute the difference. Because he is out of this local minima, the depth will increasing and the step speed is going to increase and it will go to the global minima, that is the depth of the pond. This is very important. Now both of the fishermen has reached to the goal, that is the maximum depth of the pond, where they will get their reward as a fish. If you understood this problem, then this equation will be clear to you. Okay. Now, the basic idea that is given in algorithm is that each particle is in search of an optimal, that is a data depth. Each particle is moving and hence has a velocity. At any time, no particles or no B cannot be stationary. If you see insect, they are not stationary. Each particle remember its position. So every particle has to remember like that D1, D2, D3. They have to remember, they have to store this data into themselves. So they can exchange it. He should also store his best of all observations. D2 was the best observation of fisherman at left hand side. So it is called personal best. The observation made by the fisherman left. At the left, there were three observations, LD1, LD2, LD3. So you have to remember all these things. His personal best was LD2. Though it is one of a global minima. Global minimum it was his best. Now particles in the swamp operates, they exchange information as I told you, they have discovered in the place they have visited. But you know, if you found the best food, in case of human, he won't tell anybody. I know it. This is the behavior. If you find something extraordinary for you, you say, it is only for me, I won't share it. That's why any of the mentioned algorithm do not exist for humans. Because humans do not have same behavior in the condition. When there was no food, fishermen were exchanging their information. When a fisherman at right hand side find the food, if it was a human, he won't tell. Because he stopped cooperating. This is the behavior of a human. But for insect, this no. They are true cooperative creatures. That's why they exist. Okay. So now let's see 3D representation of the simulation. So this is a pond. It's a 3D representation of pond. You can find a global minima and maxima. Both are in yellow color. You can see the visible. And this is the 3D diagram of a pond. So as I told you, at initial, you have to place particle randomly. No pre-assumption place within this pond. The point is, if you want to catch a fish, then you have to be in pond. Fish won't be bound outside pond, so there are boundaries. Okay. Now this is 3D boundary. Place randomly all particles. Random particles are placed, but they are all are in boundaries. Now we have to define boundary where we have to search. These are the boundaries. And now we have to give them a velocity. Initial velocity, random velocity, velocity in direction and magnitude. They are totally random. Pseudo, you can use pseudo random numbers. So they all are moving. So let's say how they behave. In each time scan, particle has to move to a new position. As I told you, in the fisherman example, they were changing the positions by adjusting their velocity. How velocity is adjusted? You have to remember for personal test, they were calculating a different of their personal observations. For cooperation, they are calculating a different of all of the fishermen. In our case, there was two, but if there are more than two, then you have to take a difference of all the observations made by the fishermen. So that is a global base. Weights are random, weights are to adjust the values. Now there are two, because we cannot compare each and every one observation. What we do, we find neighborhoods. As you have to communicate from this point, he will say something to his neighbor. Neighbor is geographical neighbor. Then again the next and next. So there are many type of neighborhood. Let's see what are those geographical neighbor. Who are your geographical neighbors? next person adjacent to you. Like sun city is a geographical neighbor. Like sea city is geographical neighbor in all directions. Means those who are near to you. This is one of the criteria. Like this, these three are physically connected, they are near to particle. Others are not geographical neighbors, adjacent to them. Remember it. Now next, social. What is a social neighbor? You might have the best friends, parents, those who are not sitting here. So you may have some social system by which you can say, I establish my neighborhood. Okay? Now there is a elite group. What is their neighborhood? They are not living in a same place, but they are connected. Okay? They are connected to their wealth. You are connected to the relationship, whatever it is. So the social relationship, social neighborhood is there. And the last one, you see, these are the connecting dots. They are far apart. They are not physically adjacent to each other, but they are connected to some other medium, as I told you. Now there is a global neighbor. Everybody is my neighbor. This is the extreme case. When everybody is my neighbor, then to compute difference of an n number. What is the formula? If I have n number, you have to compute difference of all numbers. C and 2. This is the difference. So this is a huge number of calculation. N minus 1 minus 2 divided by factorial of n. This is the formula. And it's a huge number, a huge computation. So in PSO or in any machine learning algorithm, we do not take this case because computation will take very large time and the result won't come on time. So we will always take social or geographical neighborhood. The easiest one is a geographical neighborhood. And how many neighbors can at least you are sitting 4 or 6. One up and one down. 4 are on the same place. So if you follow them, algorithm work fine. But if you try to compute the difference of each node with another, then it is a problem. C and 2. This is the number of computations that are required, and it is not advisable. So one easiest neighborhood is used by this algorithm is the circular neighborhood. You create a virtual circle as I draw on this diagram. There are node 1, 2, 3, 4, 5, 6, 7. Create a virtual circle who are physically connected to this virtual circle. Suppose you want to find the neighbor of 1. The immediate connection is 8 and 2. They are the physical or geographical neighbors of this node. So what you have to compute? You have to compute the depth of a Fisher connect node 1 with node 8 and 2. That's all. Two calculations. Only two difference. Then how to transmit after Fisher connect 1. Now you consider the neighbor of 8. Who are those neighbors? 7 and 1. So if you compute the neighbor of each and every node, maximum 2 operations are there. Only 2 differences are there. So it will decrease the number of operations and share this operation knowledge. So this is the best neighborhood used in PSO. Now, how to do this vector subtraction and deletion? So X is the position which says that I am here. This is my current location, and V is the current velocity, that black one. There are two things as I told you, my best and my neighbors are global. What was my observation? My observation says that I am in wrong direction is PI. It is based on my personal observation, like L1, L2, L2. but my neighbor says this is the wrong direction. Please go to this PG. This is another direction given by my neighbor. So this is a different direction. Then how to cope up with this? So we will add those things and find the addition of these two. Aggregate with some adjusted weight. I will tell you how to adjust. So you see this is an addition, this is initial velocity, this is the partial pairs, this is the vector addition, and this is the final velocity. Okay. Now this is, you see what I told you till now has been put in this equation. Now this is the equation that governs all swarm optimization. Whether it is a bat, wolf, whale, or take anyone, all are governed by this simple formula. If you understand this equation, you can create your own algorithm also. I have created 6 algorithms out of this and published papers. So let's see what it says. This V bracket, it's a vector. Consider it a linear 2D, 3D, whatever. This is vector representation. There are two constants C0 and C1, C3. C0, C1, C2, C3. Remember, they are very important. I will tell you their implications. V is the velocity, that is a current velocity. V bracket is the calculated velocity, next step velocity. Now you see there is a random multiplication and P best minus the Z. This is important. This is what is P best? It's my personal observation. As I told you, the fisherman at the left hand side has 3 observations. LD1, LD2, LD3. What is the other P best? P best was the LD2. D2 was the deepest point that I personally observed. Okay? And this present is the present depth. Whatever it is, 1, 2, 3, whatever it is. In case of at step 2, it is 0. At step 2, it is 0 because P best was LD2 minus LD2. No effect means I am at the best position. So there is no contribution in this first addition. It is 0. Now we will see C2 random G best minus present. What is this? What is G best? G best is the deepest point of all fishermen. In our case, it was RD2. Fisherman at right at that 2. It is the deepest point. What we observe. So if you minus G best and present, then it will give some value. It is saying this second part gives us cooperation. Remember, this second part gives us cooperation. If I commit, you will fall trap into a local minima. You have to remember this. Okay. Now you see C note. C note cannot be 0 because any particle in swarm cannot be a static. You have to remember this. So C0 should be a value and it should not be such larger than that it should go beyond the search space. Means the value of C0 should be like within the limits of the pond. You have to remember this. Okay. Then C1 and C2, these are very interesting parameters. You have to decide what is the value of C1 and C2. There are persons that they say, I am the best. I am the best. I don't listen anybody. In that situation, put C1 1 and C2 0. I don't want to cooperate. I am the best. And I won't listen to anyone. This is the situation. If you put C1 1, C2 0. I don't want to listen to anybody. Okay. Now take Otherwise, put C10 and C21. That means I do not have any opinion. I don't have any observation. Sir, what you tell, I will do. This is the situation now. What you tell, I will do. I have no observation, no stand. What you tell, I will do. I have no observation, no stand. Here, they are very important. So the C1 and C2 should be decided. How much you give weightage to the other depth and how much weightage you give to your own observation. They are very important in this experiment. I will tell you the importance further. But you have to remember the first plus sign give you your personal observation direction vector. Second plus C2 and other values give the value how much you listen to your neighbors. You have to remember this. This is some pseudocode. Initialize each particle. Initialize means you have to place particles with some velocity and positions, and that should be in subspace. This is the only condition. For each particle, calculate the fitness value. What is the fitness value in our example was depth? Because this is the limit. We want to reach to the deepest point of the cone. If the fitness value is better than the previous best, set the current value to the previous. Means LD1, LD2, LD3. You have to maintain a variable which has the deepest point in the cone. Okay. Choose the particle with the best fitness for all G best. Now you have to compare because every particle is advertising its personal best. You have to compare each personal best and find the best value, means the deepest point of the cone. Okay, and then compute those algorithms. Now particle velocity, each dimension are clamped with a clamping velocity. Take an example. Suppose your particle is getting a very high velocity. What will happen? The next step will be out of the pond. The next step will be, the next location will be out of the pond. This is the problematic thing. You should not do. So you should decide you are running to the food, but you should not run so fast that you miss the food and go to the outside the pond. The boat speed is so fast that you are not able to put brake when you reach at the deepest point and you cross the pond. So there is a clamping velocity that controls the subspace updation. BMAX is called. This is the algorithm chart. Start, initialize, update the time because you know the time, at what time, what is happening. Update and store weights. You have to keep track of all the weights, update velocity. Then update, store the individual best. This is important. Update the store the global best because they will change in each step. So you have to keep track that. If termination criteria is met, what is that? This is very important. There may be many points, local minima, where if our sector I found enough fish, our sector I found enough fish, though there are a lot of fish in the pond. But when you say that I have found enough fish, then you stop. Second thing, I have spent entire day now I'm tired. Time is up. Termination criteria. Though you may not reach to the ultimate depth of the pond. So there are certain criteria that have to be met. If they are met, then you should stop searching. ये थोड़ा सा सिचुएशन बैठ करके you can be धीरे धीरे पार्टिकल पहुंच जाएंगे उधर कुछ स्ट्रैप हो गए ग्लोबल उधर पहुंच गए. Why this happening? Because I have set keep up with a 1,000 iteration. Though I have reached to the solution, but after 1,000 iteration I will stop. Means it's a time. Whole day I start fishing and now I'm back for 8 hours. I'm done it okay, but I'm satisfied. So you see, this was simulation. I have told you C1 and C2, they are very important parameters. C1 signifies I will listen myself, C2 signifies I will listen to other. But there is an optimal combination, C1 plus C2 should be 4. This is very important. These should be 4. And it is emphatically known. You can put the value of C1, C2 in such a way their sum should be 4. That is from my personal finding. How to choose particles? In my experiment, I found 10 to 50 particles are sufficient. If you increase the particles, that means you are increasing computation time. Okay, you are wasting energy. C1 important to the person base, C2 important to the neighbor. As I told you, C1 plus C2, they are usually 4. Okay, Vmax, too slow or too high are unstable. When you show what is a swarm burst or swarm freeze, there are two conditions. I am giving example. Swarm freeze is a situation where all particle velocities are approaching to zero. Means swarm is not moving that, and you are still computing. Velocities are less than 1 and greater than 0. They are not moving. They are not moving the subspace. So entire form is there, but swarm is concentrated at one place. So this situation should be avoided. Second situation is swarm burst. What is swarm burst? It is a situation where velocity of the particle are so high that the next step led to the out of the subspace. Or all particles accumulate at the edges of the subspace. All are at edges of the palm. So then you will find this. So these are the two kinds of swarm burst and swarm freeze should be avoided during search. There are a lot of application, EV scheduling problem with different settings, EV charging. As I told you, what are the internal parts of the EV. But swarm, when you have a group of cars running on highway, how they behave means can they exchange energy? Suppose one of the car is battery deficient and other car transfer the energy, so they are cooperating each other. So likewise, you can place in telecommunication, data mining, power system, signal processing, function optimization, entertainment, energy control. Likewise, you can place in telecommunication, data mining, power system, signal processing, function optimization, entertainment, energy controls. They can be used. I will show you some application of this one. If you see in this video, the song is used in these movies, PSO. In fact, this army is virtual. They are not real. They are computer generated army. So they all are not riding. We do this PSO. Now this robot army, again PSO. They have been used. I robot movie. All are virtual scenes. This is a use this PSO technique. So this technique is used heavily used in entertainment. I found this very interesting. You see this, they all are swarm people. So this algorithm is used heavily in daily life also. You may be touching. So if any question, please ask. Any question regarding this algorithm? And one thing I should give you direction. If you modify this algorithm, if you add a frequency in this, then that algorithm comes in. If you add smell in this equation, whale optimization, wolf dog algorithm come into picture, which I designed. So if you remember this equation, you can design a new algorithm. Nowadays, every animal has been used by altering this equation. So if you have any question, then please ask. Yes, please.
सर जो आपने बताया स्वाम पार्टिकल स्वाम वो उसका तो ईवीएस में कैसे
इसमें
ईवीएस क्या होता
okay. EVs में, as I told you, sir has given you the internal working of the EV. Now there is a 1 EV, 2 EV, 3 EV, 4 EV. There are swarm of EVs. You know, swarm of drones. You have heard of? When drone flies, they should not collide with each other. They are using this technology. For EV, how to find the nearest possible charging station, how to cooperate. As I told you, suppose a car is dead with a battery, he start giving cooperative signal to other car on the road. I need some assistance. So car can transfer their charging battery to the other. So this algorithm can help in this regard. हाँ? हाँ, ओला उबेर की कोशिश कर। बिल्कुल। बहुत सारी वो unmanned car आ रही है. How they will cooperate? 10 unmanned car going on the road. Ola, Tesla. So how they should not collide with each other. They have sensors. They will compute like this. They should know their location. They should know their velocity as given in the equation. So all swarm drone, you know, there is a drone. There is a next version is swarm army of drone. There are 1,000 drones come, but they do not collide. Why? Because of this algorithm. Any other question? I hope you gain some knowledge about inside of this algorithm. As I told you, there are a lot of different variations. You can write research paper on this algorithm with IoT, EV, or any other application. There is, you see, in entertainment, you create virtual animations using this algorithm. Otherwise, your virtual model will collide if you don't use this algorithm. Thank you for listening.
वैसे भी ट्रैक्टर चला रहे हैं Thank you, sir, for enlightening us with the fine words of wisdom. Now, I would like to invite Professor R. K. Vivek, sir, and Garima Goswami, ma'am, facilitate to speak of the momentum and certificate to Professor Mukhyar Singh. I request to Professor R.K. and Dr. Garima Goswami ma'am to facilitate the speaker endowment and certificate to Professor Kapil Sharma sir. Now I would like to call Mr. Pradeep Kumar Verma to get a vote of thanks.
Very good afternoon. I, Pradeep Verma, on behalf of my college team and the entire faculty of the College of Engineering and College of Computing Sciences. First of all, extend my most sincere thanks to the Lord Tour. On my behalf, I extend a very heartily vote of thanks to today's esteemed speaker, Professor Mukhyar sir, from Department of Electrical Engineering, Delhi Technological University, Delhi, and Professor Kapil Sharma sir, Head of the Department IT, Delhi Technological University, Delhi, who spare their time with us in his busy schedule to take for here. I sincerely express my gratitude to the Honorable Chancellor Sri Jayanti, Group Vice Chairman Sri Manish Jayanti, esteemed member of PMU Board of Governors Sri Akshay Jayanti for their valuable guidance. I express sincere thanks to the Honorable Vice Chancellor Professor Raghubir Singh Ji, Registrar PMU Dr. R.K. Sharma Ji, Associate Dean Dr. Mamta Jain Ji for providing the necessary support. I especially thank to the person who is in the background of the event, none other than Professor Dr. R.K. Dheri sir. I am also thankful to the participants for joining here and attending the session. It is not possible to thank everyone for such an appreciative involvement in the willingness they have expressed to finish the task. So, on behalf of FOE, I thank one and all who is directly indirectly involved in making this session a great success. We thank you for being with us. Thank you.
Thank you very much, sir.
You have that privilege. You have got that. Take a side, take a side.
संभाल के थोड़ा ये बच्चे जल्दी जल्दी में निकले तो करना है।